Hey everybody, it's Miss Hill, and I'm back to solve some linear equations with you. So take a look at that word linear, L-I-N-E-A-R. So the first four letters of the word linear just spell another word, line. And basically what that's telling you is that any equation that can be considered a linear equation, when it's graphed, it is going to create a straight line. So any point that is on that line is going to be called a solution to that equation. And so what we're going to look at today is we're going to do three different examples. We are going to look at an equation that shows up with no solution. Nothing that we've got is working on that line. We are going to come up with an example, look at an example that has infinite solutions, meaning there is no end to the number of answers. And then we're going to look at a third example where there is just one point, just one solution that fits for that particular linear equation. Let me show you what I mean. So we're just going to dig right into examples, and I'm going to start with example number 1. And our equation looks like this: 3x plus 4 plus 7x is equal to 5 times 2x plus 1. Now, as a reminder from last week, the first question when I'm solving equations, the first question I need to ask myself is, do I need to distribute? And in this case, yes, I see parentheses. So that means I need to distribute. I need to distribute this 5 that's out in front of the parentheses. It needs to get multiplied by the 2x and also by the 1. So I'm going to rewrite this equation, just copying down everything else that I didn't do any distributing with, and show my distribution. So 5 times 2x gives me 10x, and then 5 times a positive 1 gives me 5. So now I ask myself, is there any other distributing that I need to do? The answer is no. I don't see any other parentheses. Question 2 in our list from last week, we asked ourselves, can I combine any terms on either side of that equation that help me create a little bit of a simpler problem? And I want to show you here on the left-hand side, I have 3x and I have positive 7x. I can combine those together and get 10x. Because if I have 3 of them and then 7 more of them, that will give me 10 of them. I still have plus 4. And then on the other side, I just bring down everything. There wasn't anything on this other side that I can combine, no terms that are similar. Now to solve the problem, I'm still combining like terms by getting terms with variables on one side and terms without variables on the other side. So I'm going to subtract my 4, right? I'm always working with addition and subtraction first when I'm undoing a problem, which means I need to subtract it off of a like term on the other side. So I don't want to subtract it off of that 10x because what I'm subtracting doesn't have an x on it. Let's go ahead and draw my balance beam. These 4's cancel. I'm left with 10x. Oops. On the other side, I'm also left with 10x. And I have 5 minus 4, so that's going to give me a plus 1. Okay, now I need to combine my 10x. This is a positive 10x, so I'm going to subtract 10x. When I subtract 10x over here as well, what is anything minus itself? Right? That's just 0. And on this other side, these guys, right, all of this cancels, and I'm still left with 1 over here. Well, does 0 equal 1? That is not a true sentence. 0 does not equal 1. So what this is an example of is a linear equation that has no solution. Example number 2, we're going to look at a different kind of equation. and what its solution set might look at like. So let's say I've got 6x plus 12 on the left, and on the right I have 2x minus 5 plus 4x plus 17. So nothing to distribute, right? Question one is what can I distribute? No distribution because I don't have parentheses. But look on the right-hand side, you have a lot of stuff that we could combine into some terms that are similar with each other. So the 2x and the plus or positive 4x, those are like terms. They both have the variable x. I'm going to use a different shape to show you. The negative 5 and the positive 17, those are like terms. Those are terms that both are without variables, so I can combine those. So let's rewrite what I have. I've got 6x plus 12. Nothing happened on the left side. On the right side, if I have 2x's plus 4 more, I'm going to get 6x's. And then if I've got negative 5 and positive 17, that's going to give me a positive 12. What do you notice about both sides of that equation? Both sides of that equation are equal to each other. Let's solve through and see what happens. So I'm going to draw my balance beam because now I'm going to start undoing my problem. And I'm going to subtract the 12 off of the left, which means I also have to do that on the other side. And I want to subtract it from like terms, so I don't subtract it off of the variable. These 12s both cancel, right? 12 minus 12 is 0. So what I'm left with is 6x is equal to 6x, still equal to each other. Okay. Let's see if I can't solve this through some more. So I can divide this side by 6. If I divide that side by 6, then I have to divide this side by 6. So what I end up with is each of these 6's cancel out, and I'm left with x is equal to x. Think about that. If I put 1 in for x to see if it would work, I would get 1 is equal to 1. Or if I put 2 in for x, I'm going to get 2 is equal to 2. So this is an example of when I have an equation with an infinite number of solutions. Any number that I could fit in, any number I would plug into x would make that true, right? Because I ended up with x is equal to x. So whenever the two sides of your equation end up equal to each other, you have infinite solutions. No limit to the number of numbers that would fit in there. So that is looking at infinite solutions. That's looking at no solution. So nothing makes that true. Let's look at what it would mean for an answer to come out with one solution. So just one answer or one point that would be on that line. Let's look at this example. Example 3. And we've got 8 times x plus 2 minus 5 on the left. On the right-hand side, I've got 6 times x minus 1 plus 23. Oof, those look rough. First question, do I have any distributing? Yes, I need to distribute my 8 and my 6. The 8 is getting multiplied by the x and by the 2. The 6 is getting multiplied by the x and the negative 1. Don't forget to take your negatives with you. So when I redo this, I'm going to get 8x plus 8 times 2 is 16 minus 5, which just brought the minus 5 down. On this side, 6 times x. 6 times negative 1 will give me negative 6 and just bring down my 23. On both sides, I want to combine any terms that are like one another, meaning any terms that either both have variables or both don't have variables. So if you look at this plus 16 and the negative 5, I could combine those into positive 11. That makes that side a little easier. Same thing over here. I've got a negative 6 and a positive 12. So if I were to do that, I'd bring my my 6x down, and I'd end up with positive 17. Now notice the sides are not equal to each other, so I'm not in an infinite solution situation. Let's solve through. So I'm going to draw my balance beam line to separate my equation. I'm going to start here on the left with the addition or the subtraction. So I'm going to subtract off 11. Again, I want to subtract off 11 off of the other side of a like term. These 11s are gone, so I'm left with 8x is equal to, I'm going to bring my 6x down. And on this side, 17 minus 11 is going to give me 6. Okay, now I'm still trying to move these around and get my variables together. So I'm going to do the opposite here of adding the 6x. I'm going to subtract it. And what I'm left with is 2x is equal to, these guys cancel, but I'm left with 6 on the other side. My final step is to go ahead and divide that 2. So I'm going to divide by 2. And I'm going to end up with x is equal to 3. So the first type of problem we solved, we ended up with it saying 0 is not equal to 1, right? So no number made that true. The second example we worked on, we found infinite solutions. We ended up with x is equal to x, meaning any number fits. This time when we solved through, we found out that the only number that makes that equation true is when x is equal to 3. So in this case, what this is called is a problem with just one solution. Okay, so let's break that down into a nice, easy little cheat sheet here. So how do I know how many solutions I have? Remember, earlier we talked about the word solution just meaning answer. And so what I'm trying to find out here is just how many answers make this equation true. So I'm going to say, well, if I have one solution, I am going to have one solution when the variable is equal to only one number. Okay, so example 3 was a one solution problem. There was only one answer. When I solved it through, it told me x was equal to blank, some number, one number. So that's one solution. I would have no solution to my equation when the equation makes a false means not true, statement. And that was example 1, right? In example 1, it ended up, when we solved it all the way through, it ended up saying 0 is equal to 1, except that that's not true because 0 isn't 1. So I get one solution when I get one answer. I have a no solution equation when my equation ends up making a statement that is not true. and I have infinite solutions, when the equation makes a statement meaning it ends up making a statement that is true no matter what value of the variable is tested. And that was example number 2. So what ended up happening in example number 2 was we ended up with the variable being equal to itself, right? And when we end up with a variable equal to itself, so x was equal to x or y is equal to y, then we can plug in any answer in that case and we will still have a true statement. So whenever that equation makes a statement that is true, no matter what value we put in for that variable, then we have infinite solutions. I hope this helped break down for you the idea of how many solutions do I have with a linear equation, and your teacher is going to take it from here and do some more practice problems. Have a great day.